This talk is brought to you by the Bamberg Mathematical Consciousness Science Initiative.
Thank you all for coming to this. Um, so one thing I wanted to say at just the start of this talk is that this talk won't contain any mathematics. Now, some of my other work does examine the details of how various kinds of mathematical concepts can be applied to consciousness. But this is a piece that takes a very high-level overview of the field of consciousness research, both where it is now and how it might develop in the future. But still, I think it'll be of interest to this audience for reasons that will become clearer later. Now, because this piece is both speculative and in some ways audacious, I was unsure for a long time about how or even whether to write this piece. But my hope is that the ideas are sufficiently grounded in plausible observations and that the grand scope of the subject matter is tempered by appropriate doses of epistemic humility. So the ideas here, they originated a number of years ago when I was thinking to myself, what would an ideal science of consciousness look like? And are we doing everything we need to do now to reach that point? Or is there instead some way in which we should shift the focus of consciousness research? So in other words, if consciousness research flourishes over the long-term future, then we might wonder what might state-of-the-art consciousness research look like a century from now? Now, obviously, any answer to this question is going to be a matter of speculation, but I want to invite you to speculate with me, even if just for a moment. So I want to paint one optimistic vision of what the future of consciousness might look like. And look, I don't know how likely it is that this vision will actually come to pass, but I wanted to start by sketching a certain grand vision of the future because it'll serve as a reference point for some points that I'm going to make later in this talk. So here's one such optimistic vision. We could imagine a future where the study of consciousness will have progressed from an emerging field into a mature science, where our scientific theories illuminate not just the conscious experiences of humans, but also those of animals and AIs, as well as humans in altered states, where our mathematical models map the spaces and structures and dynamics of conscious experiences and enable precise descriptions of their form and character, where our concepts are and taxonomies have shifted from rough distinctions that are rooted ultimately in folk intuitions to more refined tools that carve experiences at their joints. I think we could even imagine a new field of applied consciousness science that utilizes basic consciousness research to enhance technology and medicine, maybe even art and entertainment. And I mean, there's always, of course, going to be deep disagreements and unresolved debates, but we could hope for a future where there's increasing convergence across methods and language and frameworks, maybe even a future where the science of consciousness is moving in the direction of the great natural sciences like physics and chemistry and biology. And I think we could even imagine future consciousness researchers looking back upon our current theories and viewing them in a similar light to how we view pre-scientific theories of the physical world. Now, as I said, I don't know whether this scenario will ever come to fruition. Maybe it's never going to be more than just a speculative fiction. Your guess is as good as mine. But still, I think we should recognize that science often advances in ways that are hard to foresee, and the future often turns out stranger than we might have imagined. And I think that this vision of the future, I think it's at least an open possibility. And if it is, then one thing we might wonder is what questions should we ask today to move us closer to this vision of tomorrow? And if you're like me, then you think the science of consciousness is moving forward. And in fact, with great momentum, and in fact, at an accelerating pace. But you might wonder, where are we going to eventually land if we just follow our current trajectory? So my aim in this talk is to suggest an answer to this question on which direction might be most promising for the future of consciousness, basically by looking backwards, by appealing to a pattern across the history of science. Now, one thing I want to be clear about is that I think plenty of tangible progress is being made. I'm more optimistic than pessimistic about the state of the field today. The field today is diverse and rich and flourishing with all sorts of new, exciting strands of research. But I think everyone will also agree that the field today is fragmented. There are many different theories, sometimes with very different starting points and frameworks and language. And our basic methods and concepts are still somewhat rudimentary. And I mean, I have my own sympathies about which approaches are most promising and which views are most likely to be true. But I think everyone will accept that we're still a very long ways off from realizing anything like that vision of the future. But at the same time, the field of consciousness research, it's still in its early stages. In fact, I think it's plausible that we haven't yet found our Darwin or our Newton. And I think the most exciting ideas are likely still to be discovered. Maybe our theories today are going to be just rough outlines for a future science of consciousness. And obviously, we can't know the exact form of those ideas that lie ahead, but we can still ask what questions we should be pursuing now to give ourselves the best chance of reaching those sorts of discoveries. So here's the plan for the rest of the talk. I'm going to soon offer an answer as to how I think we ought to move the field forward. But I'm going to start with a question. It's a question that I'll argue in some ways captures our current chapter in consciousness research, and that sheds light on the way that the field of consciousness research today is often described and framed and portrayed and conceptualized. So to set the stage for the question, think about how consciousness is often portrayed as one big mystery, and how the field of consciousness research is often framed as the endeavor to solve that mystery. And at the heart of the mystery lies the following question, what I'll call the big question. What is consciousness? In other words, what makes it the case that there's something it's like to be a creature? What grounds the fact that an entity has a subjective point of view? What demarcates subjects of experience from mere objects? What's the ingredient that separates conscious states from unconscious states? There are subtle differences between all of those expressions, but each I'm taking to ask a version of the big question. Now, when people talk about solving consciousness, they oftentimes mean answering the big question. And when people claim that we lack a definition of consciousness, what's usually meant is that we haven't yet answered the big question. And when people talk about the question of consciousness, as though the subject matter could be distilled down to a single problem, they often have in mind the big question. So one thing you might already be thinking is, well, what else could there be to consciousness research? Isn't it obvious that the point of consciousness research is to provide an answer as to what consciousness is? And I agree that the big question is important. I even would argue that it belongs at the very center of the field. But as I'll soon explain, I think the conceptual weight of the big question can sometimes distort how we think about the scope and the target of consciousness research. So to explain why, let me first note that the big question, it's an example of what I like to call an essence question, a question about the underlying nature of a kind. So other examples of essence questions include classic questions like, what is water? What is light? What is life or language or computation? These are questions that ask what it is in virtue of which something counts as a member of a kind or an instance of a phenomenon. And the answers to essence questions can often be expressed with simple identity statements in the form X is Y. So similarly, an answer to the big question will take the following form. Consciousness is blank. How we fill in the blank will tell us the big answer, the answer to the big question. So in other words, a big answer is going to tell us what it is that makes an entity feel some way at all. And any such answer is going to draw a line in reality that divides conscious entities from non-conscious entities. If we know the big answer, and if we can determine whether an entity has the property that marks that divide, then we should be able, in principle, to determine whether any given entity is conscious. So here's a few candidates for big answers. You all will be familiar with all of these. You could think that consciousness is having a global workspace, or higher order awareness of first order representations, or having a maximal phi value, or having an internal attentional model. In fact, even a view like Cartesian dualism, where consciousness is a matter of having an immaterial soul, that's still a way of answering the big question. Now, the big question, as I'm thinking about it, it's related to the hard problem of consciousness, the challenge of explaining why consciousness arises from physical systems at all. But the big question, it's not just the hard problem in question form. So one way to see this is that the big question, it's a question of what, whereas the hard problem, it's a problem of why. And one could accept an answer to the big question without thinking that one has solved the hard problem. For example, you could accept that to be conscious is to have high order awareness while still feeling puzzled about why there's anything it's like to be a system with high order awareness. Or to put it another way, you could accept that a certain line divides the conscious entities from the non-conscious entities, but still be puzzled as to why the line lies there rather than elsewhere. It might turn out that solving the hard problem is necessary to fully justify a big answer, but an answer to one doesn't necessarily entail an answer to the other. Now, here's one of the central claims that I want to make. The study of consciousness concerns much more than the big question. And to be clear, I think the big question is important. I think it's one of the hardest questions in science, and I think it connects to some of the deepest issues in philosophy. So it deserves, in my opinion, to play a prominent role in consciousness research. But its sheer size, I think, also eclipses other important areas of research. And the study of consciousness, I want to argue, it's not merely the search for the big answer. And one way to see that is that even if we answer the big question, many questions, many further questions about consciousness would still remain open. For example, suppose we suddenly discover the answer to the big question. Suppose that we establish beyond any reasonable doubt that to be conscious is to have property X. And you can substitute in whatever you like for X. Having a global workspace, or high order awareness, or a maximum amount of integrated information, whatever. Well, then we could ask, would we then have automatically arrived at this utopic vision of the future that I sketched earlier? And I think the answer is not quite. You would still need a lot more. One way to see this is that the big answer, it's going to draw a dividing line between the space of conscious entities and the space of non-conscious entities. But it's not going to tell us, it's not by itself going to tell us how to map the space on the conscious side of that divide. So the big answer, it might help us determine whether a given entity is conscious, but it wouldn't by itself tell us what it's like to be that entity. It's one thing to know which things are conscious, but it's another thing to understand the different ways in which something can be conscious. So to take an example, think about conscious AI. To determine whether artificial consciousness is possible at all, we'll have to make progress on the big question. But even if we knew that certain artificial systems are conscious, there's still a lot of questions that would remain unsettled. For example, what are the experiences of artificial systems like? How do they differ from human experiences? How do they differ from each other? Could we ever understand the experiences of artificial systems with radically different architectures? Here's another way to express the point. Consciousness is sometimes described as a matter of the lights being on inside. And the big question, it's about figuring out whether the lights are on. But consciousness research should be aiming not only at a theory that specifies whether the lights are on, but also a theory that specifies what's illuminated. You might wonder what exactly is illuminated inside the mind of a bat or an octopus or an AI. Now, to be clear, I'm not saying that all consciousness research is focused on the big question. A significant amount, in fact, I think a significant majority is concerned with more than that. But my point is that the big question, I think, exerts outsized influence on how the field is framed. Consciousness is often portrayed as this singular, unsolved puzzle rather than this rich subject matter with many subdomains. And I think that when we treat the aim of consciousness research as simply trying to find the answer to the big question, we risk underselling both what the field is already doing and also what it could become. Now, there's no doubt that settling the big question, it would be a massive step forward. I mean, it would be like discovering that water is H2O, or that heat is molecular motion, or that light is magnetic radiation. But just as those discoveries still left open many questions about water and heat and light, so too would the big answer leave open many questions about consciousness. So finding the big answer, it wouldn't be enough to bring us to the vision of the future that I sketched at the beginning. So then you might wonder what else is needed. Well, I'm going to answer that question, but to set the stage for my answer, I want to step back for a moment from consciousness research and make a broader observation about scientific progress. So I mentioned that the big question is an essence question. And I also mentioned some other examples of essence questions. Now, each of these questions is important and interesting. But one thing you might notice is that none of these defines the scope of its corresponding science. So the fields of chemistry and biology, linguistics, physics, computer science, all of those do much more than simply answer essence questions like the ones above. It's not like chemists today are sitting around pondering questions like, what is water? What is gold? I mean, maybe those questions animated very early stages of inquiry, but they're not focal points in contemporary science. If you think about the kinds of questions that contemporary scientists in these respective fields are going after, they seem very different from the kinds of questions that are listed here. So I think it's useful to contrast essence questions with another category, which I'm going to call structural questions. These are questions about modeling and mapping, measurements, and mechanisms, rather than about underlying natures. They're canonically questions expressible in the form, how do we model X, rather than what is X? So here are some examples of structural questions drawn from the same scientific domains as above. We might wonder, how do we model fluid dynamics? Or what are the mechanisms of reproduction? Is light continuous or discrete? What are the basic building blocks of syntactic trees? What are the most efficient algorithms for a given computational task. Now, structural questions in general might concern the space of possible states of a system, or the dimensions along which members of a domain vary from each other, or the parts into which an object can be decomposed, or the relations that a kind bears to other kinds. And more broadly, structure concerns the features that can be wholly captured through mathematical descriptions. So structure, in this sense, kind of metaphorically, it's a matter of form, meaning variation and pattern and quantity and composition, rather than a matter of intrinsic nature. Now, here's an idea that I think is pretty striking, and which is one of the key ideas that inspired this whole project. I think there's a certain kind of pattern that occurs across the sciences, which is that as a scientific field matures, its focus tends to shift from essence to structure. So, for example, take chemistry again. Classic essence questions in chemistry include what is water and what is coal? And as I said, the answers to these questions, they were amazing discoveries. But the science of chemistry does much more than just answer these essence questions. In fact, one of its most significant breakthroughs, the construction of the periodic table, that's a discovery about the systematic relationships between chemical elements rather than about the nature of any particular chemical element. And this kind of pattern recurs in other fields. In general, essence questions seem to rarely play central roles in state-of-the-art research, at least for mature scientific fields. Instead, they're most prominent in early stages of inquiry, when the target phenomenon is still poorly understood, and when we lack the tools and frameworks that are needed to craft structural questions. But then as a field matures, the center of gravity seems to shift from essence to structure. There's a really nice illustration of this in this well-known book by Hasok Chang called Inventing Temperature, which basically traces the development of thermometry and shows how much of the progress in that field was driven by questions about modeling and measuring temperature. And that's an example that illustrates not just the transition from essence to structure, but also how we often discover essences only by investigating structure. Now, I'm not saying that essence questions just vanish entirely. So there are still essence questions in mature scientific fields. So for example, sometimes advances in a field lead to new essence questions. For example, what is dark matter? And also sometimes old essence questions return in new forms, like what is intelligence? But over time, the most foundational essence questions, they tend to migrate from the realm of science to the realm of philosophy. For example, questions like what is life, what is language, what is computation? Those are questions that are more likely to be investigated today by philosophers than by the corresponding scientists. And even when contemporary scientists in these fields investigate essence questions, for example, think about what is working memory or what is quantum entanglement. Those investigations still tend to revolve around a cluster of structural questions. So I think when we look across different sciences, a certain pattern emerges, which is that scientific inquiry tends to evolve from essence questions to structural questions. And I think that this pattern might hint at the future of consciousness research. So let me turn now back to consciousness. So conscious experiences are richly structured. For example, think about how your perceptual experience can be decomposed into different sensory modalities like vision, audition, olfaction, and so forth. Or think about how your color experiences vary in dimensions corresponding to hue and saturation and brightness, and how similarity relations between color experiences can be modeled mathematically using, say, a metric space or a graph. Or think about how your pain experiences come in different magnitudes depending on how intense they are, or how your spatial experience in your visual field decreases in acuity from its center to its periphery. So these are all observations of structural features of your conscious experiences. And in fact, here are some of the most foundational questions about the structure of consciousness. Um, we might wonder, are there atoms of consciousness? Does consciousness come in degrees? What are the dimensions of consciousness? Are conscious experiences continuous or discrete? Is every conscious experience maximally unified? Are conscious experiences compositional, analogous to how language is compositional? What are the geometrical structures of quality spaces? How is the state space of experiences structured? And maybe most generally, how should we mathematically model conscious experiences? Now, one thing that's worth noting is that the term structural is used in two different ways in the context of phenomenology. So there's the mathematical sense of structural, which means roughly the features that can be wholly captured through mathematical descriptions. And then there's the invariance sense of structural, which means roughly the universal features that are essential to every experience. And these concepts interact, but they're also dissociable, and it's important to at least conceptually disentangle them. So, for example, invariant features of experience, they can be described mathematically, but so too can variable features of experience, like, say, the particular arrangement of color qualities across your visual field at this moment. And whenever I talk about structure or use the term structural, I'm going to mean the mathematical sense of structure. Now, these structural questions about consciousness on the slide, they can all be contrasted with the big question. Because even if we answer the big question, we're not necessarily going to answer these questions. I've actually seen sometimes people express an opposing thought to what I just said, that to make progress on structural questions about consciousness, we would need to first answer the big question. And I think it's certainly possible that answering the big question will help with answering structural questions. But it's also worth keeping in mind that in general, it's possible to know the essence of a kind without understanding how to think about its structure. So, for example, we might know that computation is the implementation of algorithmic processes without understanding, for example, the space of computational complexity classes. Or we might know that water is H2O without understanding fluid dynamics and phase transitions and so forth. And in fact, I think the history of science tends to tell the opposite story from this objection. Oftentimes, we answer an essence question only by making progress on structural questions. So, for example, the nature of genes, that became clear only after the discovery of the double helix structure of DNA. And similarly, the equations of thermodynamics that helped lead to the discovery that heat is molecular motion. So I think it's at least possible that consciousness research is going to follow a similar arc where we might not fully understand what consciousness is until we have a better understanding of the structure of consciousness. Now, when we're studying the structure of consciousness, we're in some ways mapping the state space of conscious experiences. There's a vast realm of possible conscious experiences. And we directly access only a tiny portion of that space. And to answer the big question, so to find the essence of consciousness, that's to identify the universal property that unites this whole space. But my point is that the aim of consciousness research ought to be not only to figure out what's common across all conscious entities, but also to analyze and map the structure of this space. The investigation of the structure of consciousness, it's also related to what Anil Seth has called the real problem of consciousness, the search for systematic mappings between brain states and conscious states. But to construct such mappings in the first place, we're going to need a better understanding of the structures of conscious experiences themselves. And in particular, we're going to need to develop better maps and models of phenomenology. Otherwise, we're going to basically be trying to build a bridge or a bunch of bridges between neural states and phenomenal states without really understanding at all what lies on one side of that bridge, without knowing how to think about the terrain on the phenomenal side. Or to use a more mathematical analogy, it's kind of like trying to define a function without any understanding of the structure of the codomain. Now, to take a slightly more concrete example, the example I always like to turn to is color experience. So color experiences stand in systematic structural relations to each other. For example, red is more similar to orange than to green. And these similarity relations can be represented using a quality space model, meaning a mathematical representation of a domain of qualities. And the idea is that we can represent the similarity relations between color qualities geometrically. So color qualities that are more similar to each other correspond to points that are closer in this geometric space. And in fact, I've argued in previous work that we actually need a richer mathematical framework for modeling the qualities of conscious experiences, where we represent individual qualities as regions or perhaps distributions rather than points in mathematical spaces. And when we make a basic move like that, then we open up all sorts of new interesting questions about the mathematical structures of conscious experiences. So this is just one concrete example of the kind of endeavor that I have in mind. Now, I also wanted to make a general point here, which is I think one of the most exciting developments in recent consciousness research is the application of mathematical tools to the understanding of conscious experiences. And a few years ago, when I would describe my research interest to people, um, I would sometimes mention the speculative field of mathematical phenomenology, by which I meant the application of mathematical tools to the study of the phenomenal characters of conscious experiences. But the idea, especially obviously in in the context of this workshop, the idea is becoming less and less speculation and more reality. And in my opinion, mathematical phenomenology is going to be essential to moving the field of consciousness research closer to that vision of the future that I drew. In fact, here I want to raise an analogy. Think about how formal semantics enrich the study of language. So there's obviously a lot that you can learn about language without knowing any formal semantics. But the development of formal semantics enabled us to pursue certain questions about language in a much more systematic way. And I think in the best cases, formal tools not only helped us understand questions that we were asking before, but they also allowed us to start asking new questions using new expressive resources that we weren't even in a position to inquire about previously because we previously didn't have the concepts or the frameworks needed to formulate those questions. So I think that the application of formal tools to conscious experiences is promising for similar reasons. Now, on that point, um, it's worth noting that structural and mathematical approaches to consciousness have really been starting to gain traction in recent years. There's now this flourishing movement of research into the structure and mathematics of consciousness, led in part by Johannes, but also supported by this broader community here. But I think that one big missing piece right now is that there's no general framework for thinking about the structure of consciousness that can bring some unity to the field. So to crystallize this idea, imagine a hypothetical common model of consciousness, meaning a widely accepted framework for systematically describing the structures of conscious experiences that can guide and unify future consciousness research. So one comparison I like here is with Newtonian mechanics, which totally transformed our understanding of space and time and matter. Now, here, obviously, that didn't turn out to be the final theory. It was later superseded by quantum mechanics and also relativity. But Newtonian mechanics was still revolutionary for advancing our understanding of the physical world. Because prior to that, our grasp of the physical world, it was largely qualitative. And what Newtonian mechanics offered was a systematic structural framework that unified a wide range of physical phenomena and formalized our understanding of the physical world. And in my view, one of the big challenges facing consciousness research today is the lack of a common model. I mentioned at the beginning how the field of consciousness research is fragmented. There are different approaches that operate with different methods and theories and guiding assumptions, and also different vocabularies. So it's very hard for researchers across different areas to coordinate with each other for this reason. And I think a missing piece of the puzzle is a framework and language that enables us to formulate disagreements between specific theories uh, within a common language. So then you might wonder, well, what might a common model of consciousness actually look like? And well, at this stage, it's quite hard to say. I do have a number of ideas about how to best develop a common model, but I'm going to save that for another talk, partly for limits of time. Instead, what I want to do at this point is briefly turn to a natural thought that maybe not too many people in this audience will have, but I oftentimes encounter when I express these sorts of ideas, which it's a thought that is connected to a puzzling observation, which is that models are good at describing structure, but consciousness seems to be more than just structure. It also has qualitative character. So you might wonder whether there's a key difference between consciousness and other targets of scientific inquiry. It seems like any model of consciousness can't reveal the qualitative character of experience. Even the richest structural description seems like it's going to be bound to leave something essential out. But then you might think, isn't that missing ingredient exactly the thing that we're trying to investigate? So I think this leads to a puzzle, which is if structural descriptions of conscious experiences leave out qualitative character, then, I mean, how could the future of consciousness research lie in studying its structure? And I'm going to explain in a moment how I think this puzzling observation can be resolved. But let me first turn to an interlude um, about a famous passage in the literature on consciousness that presents a closely related puzzle. And this brings me to the very last part of this talk on objective phenomenology. So the idea of objective phenomenology, it arises from a cryptic remark from what's probably the most widely read article in contemporary consciousness research, namely Thomas Nagel's What Is It Like to Be a Bat? And there's this very well-known passage towards the end of the article where Nagel speculates about the possibility of an objective phenomenology or a way of characterizing how conscious experiences feel that would be understandable even by those unable to have the experiences in question. So here's the relevant passage. He said, setting aside temporarily the relation between the mind and the brain, we can pursue a more objective understanding of the mental in its own right and objective phenomenology. Although presumably it wouldn't capture everything, its goal would be to describe, at least in part, the subjective character of experiences in a form comprehensible to beings incapable of having those experiences. So, in other words, is there a way of describing bad experiences that could be understood even by humans? And you might reasonably think that, well, it's not clear that such an endeavor is even coherent. Because to understand what it's like to be a bat, one must have had experiences sufficiently similar to a bat's experiences, but humans, by necessity, seem to have a bounded range of experiential capacities. So maybe that imposes principled limits on our epistemic access to other kinds of experiences. And maybe those limits would shift if we were somehow able to acquire new experiential capacities. But given the kinds of creatures that we are, with the experiential repertoire that we have, it seems like it's impossible for us to fully understand what it's like to be a bat. Now, obviously, bats are just an example here because the core problem is general. How could we ever understand what it's like to be a creature whose experiences are radically different from our own? It's one thing to think that we might be able to eventually find out whether, say, slugs and fetuses and AIs are conscious in the first place. But it's another thing to think that we can come to understand what their conscious experiences are like. So we're left then again with a puzzle. There's this idea of an objective phenomenology, which feels intriguing and appealing, but you might wonder, is it genuinely intelligible? And I think the puzzle about modeling consciousness and the puzzle about objective phenomenology actually share a common solution. And the solution is that the way an experience is structured is itself an aspect of its phenomenology. So, what an experience is like, it depends not only on which qualities are present, but also on how those qualities are arranged and how they relate to each other. So, for example, a full description of your visual experience right now, it would have to mention the structure of your visual field, the distribution of qualities across it, the similarity relations between those qualities. And I think to describe the structure of an experience is therefore to describe one aspect of its phenomenology. So a structural characterization of an experience, on my view, is both objective and phenomenal. It's objective because it can be grasped even by those unable to have the experience under question, and phenomenal because it describes, at least in part, what that experience is like. So think again about what a common model of consciousness might reveal about the experiences of bats or octopuses or or AIs. It wouldn't enable us to simulate those experiences firsthand, but it might still tell us whether echolocation experience um, is like a series of discrete pulses or instead a continuous stream, or whether each of an octopus's tentacles is itself associated with a partially independent stream of consciousness, or whether an AI's experiences contain, say, any counterpart to our visual field. And those structural descriptions would still capture, in part, what it's like to be a bat or an octopus or a conscious AI. Now, when the experiences in question lie really far beyond the bounds of human phenomenology, it might be that we can only glimpse a faint trace of their qualitative character. But I think that descriptions of their structure would still be accessible to us, at least when they're cast in formal mathematical terms. And in my view, even the most abstract structural descriptions that are stripped of any qualitative content, they can still illuminate the contours of an experience, even if it leaves out its qualities. So this is something, these are some ideas that I developed in much more detail in the paper mentioned at the bottom of this slide. But what I just expressed captures the essence of the idea. Now, one thing that's worth saying is that in my view, even an ideal model of consciousness won't fully capture what it's like to see red or feel pain or smell cinnamon. And that's because, in my view, consciousness is more than just structure. But the fact that consciousness is more than just structure, that doesn't diminish the interest of mapping and modeling its structure. One way to put this all a bit more metaphorically is that even when we're in the dark about the intrinsic qualities of an experience, we might still be able to study its blueprint. And I think that when those qualities are really alien relative to our own experiences, then it might be that the blueprint is the most that we can do. Now, I mentioned that there's not actually any mathematics in this talk, and it won't have any um, formal stuff. But let me give you just one tiny equation before I end. If what I've been arguing is correct, then to engage in mathematical phenomenology just is to undertake an objective phenomenology. And that's because mathematical phenomenology describes the mathematical structures of conscious experiences, and facts about the mathematical structures of experiences are objective phenomenal facts. So for any of you undertaking research in mathematical phenomenology, you've been vindicating this whole time that cryptic and curious passage from Nagel's article. Now, to wrap things up, um, I started by sketching this vision for the future of consciousness research. And I motivated it by appealing to a certain pattern across the history of science. And the study of consciousness, I've argued, it's about much more than just what consciousness is. Because answering the big question, that would solve a major mystery, but it would still leave open many questions about the kinds and characters and also structures of conscious experiences. Now, the structure of consciousness, um, that's still a pretty underexplored topic, but it's gained a lot of momentum in recent years. So one thing you might actually wonder is whether consciousness science is already in a historical transition. Maybe we're currently moving from an essence phase to a structural phase, from more speculative beginnings to a more systematic science. But I think to fully reach that stage, we would need something like the kinds of structural breakthroughs that have transformed other fields. For example, we might hope for an analog in consciousness science of Newtonian mechanics or Darwin's theory of natural selection or Mendeleev's periodic table of elements or maybe Turing's theory of computation. And maybe we'll acquire that breakthrough by trying to construct a common model of consciousness. And as I said, what form that model might take, that's an open question. But I think we can be sure that constructing it, building that model is going to require moving beyond the big question. Now, I started this talk with this sketch of a vision for the future. And as I've emphasized, I don't know whether that future will ever be realized. But I also asked what questions we should be thinking about today to move us closer to that vision of tomorrow. And I've now offered an answer. I think that if consciousness research is going to follow the arc of the most successful sciences, then its future is going to lie in asking not just what consciousness is, but also in mapping and in modeling its structure. Because, I mean, that's the pattern that we find across the history of science. And in my opinion, that might be the most promising path for the future of consciousness research. Okay, thank you for listening.